This tutorial corresponds with your sketching practice handout. Please follow along with your handout as you view the tutorial. Pictorial sketches. Just think about what pictorial might mean. It's a picture and it's a sketch. So in a pictorial sketch, you wouldn't necessarily need to use a straight edge, but it should represent the shape of the object. It should show the height, width, and depth of the object. And common types of pictorial sketches are isometric sketches and perspective sketches, and we'll be going through what those two different types are. First, the isometric sketch. This is a sketch that shows the width and depth lines drawn at a 30-degree angle from the horizon line. So in your handout, you're asked to create two different isometric sketches, and these sketches will, similarly like this cube, will show the height, width, and depth of the object. And I'd like you to go ahead and create two different objects that I will tell you in class, because depending on the class, it may be one class is sketching one item and another is sketching a different one. So I hesitate to put it in this video. If I've forgotten to tell you what I want you to sketch in the beginning of this handout, then please just let me know that I've forgotten to give you the two items that I want you to sketch. So pause this video and then go ahead and make the two sketches. So the two sketches you just made were on plain white squares, but a technique you can use when making an isometric sketch is to use isometric grid paper. This helps with determining the right angle for your sketch. When creating an isometric sketch for a project presentation, you can create a more professional look to your sketch by turning the paper over and drawing the sketch on the white side of the sheet, but still using the grid. You can sort of see through the paper to the grid. That way your finished product will look cleaner if it's on the white side of the paper. A thumbnail isometric sketch. I want you to go ahead and copy this onto your handout in the space provided. Make sure that you label the cube, and at this point I'd like to see clean edges, so you will use your straight rule for creating the lines of the cube. This next activity will be helpful in demonstrating how you can use the additive subtractive method of sketching. So an isometric sketch shows an object in which the width and depth are projected at 30-degree angles from the horizontal axis. That's repetitious a bit, but worth restating. Then the height, width, and depth values are all at the same scale. So you're going to follow the steps now in your handout to complete this drawing on the isometric graph provided at the end of those steps. Now you should have finished creating your thumbnail sketch using the additive and subtractive method. Perspective. Perspective is a way to draw that shows a view of an object in the most realistic way. Vanishing points are used to guide the lines in the object to the horizon line or the horizontal line you see at your line of sight. So my line of sight here is straight on the front of, we'll just say this is a barn, and I can see that this pentagon is a regular pentagon. There's nothing angled about it. It would be the same as if I was doing the two-dimensional shape. And here's my vanishing point. Since there's only one vanishing point, this is actually an example of a one-point perspective. In this example, you'll notice that all of the lines in the depth project to one point, that vanishing point. The location of the vanishing point is based on your line of sight. So we can imagine then that we are looking at this object in a manner in which all of your depth lines will draw back toward that vanishing point. Perspective drawings use vanishing points. So in your first drawing, you have a single vanishing point, and as mentioned, what you would use at the station point is the front of your image, and then draw lines to the vanishing point in order to create that perspective. So let me show you how that's done. First, your main image. So here I have a pentagon, and one of the vertices or corners of that pentagon is resting on the station point. Once I have that drawn, and notice that it's kind of a gray color, what I want you to do is first draw lightly your image, and once we have the final image, we'll darken it with your pencil. Also remember to use your straight edge. It doesn't have to be a ruler. It can be the edge of your notebook, but you need a straight edge, and it's easy to tell no matter how straight you attempt to create those lines, whether you used a straight edge or not. Once you have this shape, then the face of your object, then you're going to take each vertice and with your straight edge connect that vertex to the vanishing point. So there's the first one and the second one and the third one and the last one. And I don't do this one because I wouldn't be able to see that behind the object. Okay, then I take lines that are parallel to my original shape or the front of that image, and I decide how long I want that object to be and draw those lines. So you'll notice that this is parallel with this line, and the next one will be the same. Okay, and now I have these three lines. Again, I don't do this one because it would be hidden behind. Okay, then darken your shape. I'd like you to copy this 1-point perspective sketch onto your activity in the space provided. Make sure you label the front, top, and right side. Go ahead and pause this video again to complete that part of the activity. In the 2-point perspective, you have width lines that converge on one vanishing point. So the width of this object is converging on vanishing point 1, and then the depth lines are converging on yet a different vanishing point, in this case vanishing point 2. Unlike the single vanishing point, this time you will start with the corner of your object, which means I'm just going to have a vertical line drawn up from the station point. And then with that line, I now will connect it, and I'm drawing lightly at first again, connect the bottom of the line to one of the vanishing points, the top of the line to a vanishing point, and the same to the other vanishing point. Okay, now I determine what that shape is, and I guess I should already know before I begin what that shape is, but in my case it's a rectangular prism. So I have the front of my shape right here. This is actually the right side of my object, or the right edge, not the right side. The right side is over here. Okay, so the right edge of the front face. And then I'm going to determine the length of my rectangular prism. And it's important to recognize that these lines are parallel. When you extend the edges of your shape, you always need to remember that they are parallel in perspective. And once I have those lines drawn, now I connect those also to the vanishing points. And I do not connect this vertex down here because that's a hidden line. And then darken my shape, and there it is. I'd like you to copy this 2-point perspective onto your activity sheet. And again, label the top, front, and side. Be sure to pause this video and complete this part of your activity before moving on. Now you've completed the isometric portion of your activity. Let's take a look at orthographic multi-view drawings. Pictorial sketches help engineers explain ideas and communicate to the customer what the final part will look like. But unfortunately, pictorial drawings have some disadvantages. They have foreshortened views and distorted features that don't allow for accurate prototyping. In order for parts to be accurately depicted, you typically need views that directly portray each surface. The arrows represent the line of sight associated with each view. So bottom, right, and so on. An object possesses 6 views. Notice the similarities between the front and back, and your top and bottom, and your left and right. They're not exactly the same, but very similar. An orthographic multi-view sketch then will show one of each of those like views, we'll say. So the front and the back were very similar. We only need to choose one. So typically we choose the front. Top and bottom were very similar. So we choose the top. And the right and left sides were very similar. So we choose in an engineer's drawing the right side. In order to obtain these straight line views, we have a type of drawing called orthographic projection, also known as multi-view drawing. An orthographic projection is a way to project a view based on a line of sight that is perpendicular to that view. So when I say perpendicular to that view, what I mean is when I look at the front of that object, I can go right above it and show the top view, and go directly to the right and show the right side view. So in that sense, these other two views are perpendicular to the front. I want you then to copy this orthographic sketch onto your activity sheet. It's number 9. Label the top, front, and right side. And don't forget the hidden lines. Remember that hidden lines are represented by dashed lines, and contour lines are solid lines. So this is representing kind of a corner, if you will, or edge of that object. Go ahead and pause this video and create these 3 views of an orthographic sketch. You should now have the front, top, and right side view drawn on your activity sheet. And now we'll talk about the orthographic view selection. Finding the best view of a part can sometimes be difficult. It might seem like 2 or more sides could be the best choice for the front view. So what you want to consider are these 4 main details when selecting the front view. First, which side shows the best shape or details of the object? Which side shows the longest dimensions of the object? And which side shows the fewest hidden lines? Finally, which side shows the most natural position of how the object would be used? If I look at number 2, I see that these details are not hidden. That looks like a good front view. So just think about these 4 things when you're deciding which view is the best front view. When drawing lines, there is such a thing as precedence of lines. Object lines exist over hidden and center lines. Object lines are the edges of the object, and hidden lines are edges that are hidden behind. And then center lines, in this case, the center of this drilled hole is represented here. Hidden lines exist over center lines. So in multi-view drawings, different line types often compete for space. Therefore, we have line precedence. Object lines exist over hidden and center lines. In example 1, the object line takes precedence over the hidden lines that you'd see from the hole in example 2. So here's your object line, this one right here, that would also correspond to this hidden line of the edge of that hole. So we don't see the edge of the hole in the top view because this takes precedence. In example 2, an object line takes precedence over the center line. So see how the center line, this one right here, would be right here in the same line as this object line right here, this corner of the two edges converging, so we don't see that center line. It's best represented in my top view. Something you might notice, however, is that in this object line, it's actually extending beyond the object. That's to show that underneath this object line, there is this center line that would extend out from the sides. Hidden lines, by the way, exist over center lines. I don't have an example of that in this slide. You should now have all the information you need to have completed your packet, except for the final concluding activity, where it says your teacher will provide you with an object to sketch as well as isometric and orthographic graph paper. I will let you know in class, depending on your class, what that object will be.